Welcome to today's webinar, Oracle October 2011 Critical Patch Update, Oracle Database Impact. My name is Phil Ryman. I'm the Director of Business Development at Integrigy, and I'll be the moderator for this e-learning session. Speaking today is Stephen Kost. Stephen is the Chief Technology Officer and founder of Integrigy Corporation. He's been working with Oracle products since 1994 with responsibilities that include database administrator, technical architect, IT security auditor, and applications administrator. For the past 12 years, Steve has focused on security and auditing aspects of the Oracle Business Suite and the Oracle Database, and has written and presented on these topics at various national and regional conferences, including OAUG, IOUG, and the National Collaborative Conferences. Steve is recognized nationally for his vast security knowledge and expertise. So now I'll turn it over to Steve.
Thanks so much, Phil. So today we're going to delve into the Oracle Critical Patch Update, specifically for October 2011, and really look at the database impact. The Critical Patch Updates include a lot of different pieces from Oracle, including the Oracle Business Suite, Oracle Application Server, Siebel, PeopleSoft, Sun products, and we're just going to look at the vulnerabilities and the impact for your Oracle databases. Last week we did a webinar on the Oracle Business Suite, which is actually available on our YouTube website. If you want to see a recording of that, you go to youtube.com/Integrigy, and you can actually see all our videos from past webinars. So let's get started and start talking about the Oracle Business Suite, or the Oracle Database impact for the Critical Patch Update. A little background about Integrigy before we get started. For those of you not familiar with Integrigy, we specialize in Oracle Database and Oracle Business Suite security. We have a product called App Sentry that will help do security assessments against Oracle databases, and we also have a number of security services related to securing Oracle databases at enterprise-wide level and individual critical databases you might have. So enough about Integrigy. Let's just give you a little background and know where we're coming from. One of the questions that we often get at Integrigy is how much do you know about the Critical Patch Updates and how do you know it? Well, we've found over 72 bugs in the Oracle security products over time, and those bugs include a number of Oracle database bugs and other things, and a number of Oracle Business Suite bugs. And so those security bugs are fixed in the Critical Patch Update. So we spend a lot of our time actually going through and trying to discover security bugs in both the Oracle Database and Oracle Business Suite. So we'll talk about the Oracle Critical Patch Update for October 2011, and we'll do a background first about the CPUs, give you a little bit of information about how the CPUs are and some of the key information. Then we'll specifically talk about vulnerabilities that were found in this CPU, then talk about patches for this core CPU, and then talk about a patching strategy. So let's first talk about the Oracle Critical Patch Updates at a high level, kind of give you some background to some of the things that Integrigy looks at when we talk about the Critical Patch Updates. So the Critical Patch Updates have been around since January 2005, and prior to that, Oracle was releasing security patches one-off. So they would basically find a security bug, fix it, and just one day send out an email unbeknownst to anybody that, oh, by the way, this is a security patch, you need to start working and fix it. Prior to that, also, Microsoft had come out with a monthly security patch process. And the Oracle customers were really kind of clamoring at Oracle saying, well, this needs to be more defined. We need to know exactly when they're going to come out. And that's when Oracle moved to the quarterly release cycle. And what they're trying to do is avoid your month-end close, year-end close, other key dates. And so they kind of settled on January, April, July, and October, and they're doing the 17th date. It used to be the 15th. They moved it back to the 17th to kind of typically move it for most quarters back 1 week, even more. So there's been 28 CPUs to date, fixing an astounding 1,300 security bugs. On average, there's 48 bugs per CPU. And these numbers that I'll talk about today have all been normalized. We've removed the Sun products, so these really only include the Oracle Database, Oracle Business Suite, Oracle Application Server, and Fusion Middleware, and some of the other major Oracle applications. So in the Oracle Database, there's been 524 bugs fixed in 28 CPUs released to date. So that's a pretty significant number of bugs. So one of the questions we get quite often is, well, these bugs have to be stopping. Oracle's got to have fixed them all. Well, this chart here shows, and you can see the bar graph with the blue, is the number of database bugs fixed per quarter over the last 28 quarters. As you can see, the numbers are dropping somewhat, but talking to other security researchers, we know there's probably at least 50 to 100 open bugs with Oracle today, specifically on the database and some of the other key products. So these CPUs will be coming, in our estimation, at least for the next year, probably the next 2 years. They'll be kind of still a steady stream with enough critical database bugs for you to pay attention to. The squiggly lines to the upper right are actually the CVSS scores. And I'll talk about the score, but basically it's an indication of how the most severe bug in the patch. As you can see, relatively the bugs are consistently high. Anything over a 7 is very critical for a database bug. And even a 6.5 or a 5.5 is a pretty serious database bug. So there's at least one critical bug per database CPU. So even though you may think, well, those don't look severe, there's probably one that's meaningful in your organization. Another aspect of the CPUs that a lot of people don't realize is the way that bugs are actually fixed and the time frames and some of the nuances. The first is a customer like yourselves or a security researcher reports the bug to Oracle. Oracle pretty quickly actually confirms that the bug exists. They do that within 1 to 2 or 3 days in our experience with Oracle. And then they develop a fix. One of the key aspects of when they develop the fix is they don't actually let the security researcher know, or the person who found the bug, what the fix is, or even let you test it. It's kind of a black hole. You release the bug to Oracle, they work on it, then all of a sudden it pops out on a CPU one day and you have no idea how they fixed it or anything like that. And that's actually caused problems historically because about 5% of the CPU bugs in our estimation for the database are actually refixes or fixes in the same piece of code. So Oracle will actually fix it, but may not fix it completely, may not fix every use case or test scenario, or may miss in the next function down. They may fix it in one function, but they may miss the next function has a very similar bug. They've been doing a much better job of that recently, but historically, 3 or 4 years ago, a lot of bugs found were actually refixes or fixes in the same code. You'd see one database package being fixed 3 or 4 times in 3 or 4 CPUs. And what's happening there was Oracle wasn't fixing it properly or was finding it in one function that was reported, then didn't look down the next 3 functions and say, oh, by the way, it's there too. One of the key aspects here also is Oracle includes the fix in the main code line first. And so it may actually be in a new release prior to the release of the CPU. And then what Oracle does is actually re-engineers all the patches. And for the Oracle database, that may be 30 to 50 different patches based on version and platforms. And then they release the CPU fixes. And that may be 3 months to 3 years. Oracle is doing a much better job today than they were historically getting bugs fixed in the 3 to 6 months time frame. But bugs can be open for up to 3 years. And so that is and can be pretty significant for a lot of bugs. So as I talked about the Oracle security process, so when Oracle is actually fixing the bugs, they're fixing it in the main code line first. The impact and problem with this is that Oracle's notified, they fixed in the main code line. So most people assume scenario A, the top bar there, is what's happening. Well, then they release a CPU, it's created and released, and then eventually a new version comes out. What actually happens in many cases, for many database bugs in particular, scenario B happens. Someone notifies Oracle, they fix in the main code line. Then they go through this arduous task of actually backporting that patch and testing and regression testing that fix to all the platforms and all the versions. So right now there's 5 or 6 versions. There may be 10 platforms. So that's at least 50 patches that actually have to be individually developed and tested. So a lot of times what happens is that a new version's released. So 11.203 was just released for the database. Well, there is no CPU fix this quarter for 11.203 because what happened was all these fixes were included in the 11.203 main code line when it was being developed. And so when it was released, there were security fixes that no one realized. And so the impact here is when you're actually upgrading to a new version, you might be getting security fixes that are not documented anywhere. So there is one slight advantage to upgrading to the latest and greatest releases from Oracle is that often they contain security fixes that have been unannounced and unreleased in other products. So another area that I talked about was CVSS scores, and we'll jump out to the advisory. I'll show you a few things in a minute here. But basically, Oracle gives a number for each vulnerability they fix, and it's called the CVSS score. It's a Common Vulnerability Scoring System. And what happened was a number of years ago, the major security companies working with the vendors came up with a standard method to rate security vulnerabilities across all products. And this includes operating systems, network devices, databases, applications, just about everything. And most major companies are referring to it. Microsoft uses it, Oracle, Cisco. So key vendors that you're probably working with on a daily basis use CVSS scores. The problem was the original developers of CVSS were basically people who are mostly working with operating systems and network devices, not databases. And so their definition of a CVSS score was to have a 10, you had to basically take over the entire device. And they're very specific in the standard saying device, server, not database. And so their definition of a 10 is not you can take over the entire database. Their definition of a 10 is you can take over a server and obtain root access. Well, on a database, most likely for many of the vulnerabilities, and I'll show you those for this quarter included, I can take over the database very easily, but it's very, very difficult on Unix or Linux systems to actually get root access. And so what this means is the CVSS scores will always really be low for Oracle. It's really more of a problem with the metric, not the way Oracle's kind of bias it and be evil and say, well, our vulnerabilities aren't as high. It's really generally a problem with the CVSS scores in general, just because they're biased towards root access. They're not really meaning to say the entire database. If you kind of look through some of the mailing lists and discussions about CVSS scores, the original developers all kind of acknowledge that this is a problem and hopefully it will be addressed in the future. One way Oracle compensates for this is to actually include partial plus in the advisory. So when you're looking through the advisory, and we'll look at one in a second here, they include partial plus. So that means you can take over the entire database, even though in CVSS parlance, you can't complete would be the highest rating there, would mean you have to take over root access. So Oracle saying, well, yeah, this is pretty serious. Yes, I can compromise the entire database, but unfortunately I can't get root access. So when you look at the CVSS scores, think of a really serious vulnerability. There will be 8, 7s, and 8s, but a 6.5 is a very serious Oracle database vulnerability. And where for most DBAs and other Oracle technical people, this probably isn't a daily impact. Where it will impact you is if you are talking to your chief security officer or someone else in IT security and start talking about vulnerabilities and say, wow, we've got this very serious Oracle vulnerability at 6.5, we need to get this patch. And they'll say, what are you talking about? We have 10s all the time on our network devices and operating systems. We can barely keep up with those. A 6.5 is not meaningful. And this is where you'd have to explain to them, oh, by the way, a 6.5 means I can steal all our corporate data, steal our entire HR database, and sell it off to China or somewhere. So what we'll do right now is kind of jump out quickly to the actual advisory for this quarter. I'll kind of show you some information that we look at when we pull it up at Integrigy. So I've kind of pulled up the advisory here. So this is if you go to the Oracle website and or search in Google Oracle CPU, it's the first hit. So one of the first things you should be aware of, Oracle does publish out very clearly all the different dates for the future CPUs. So you know very clearly when the next CPUs are going to be released. And so when you're doing your planning, you should be aware of these dates and try to include it in your cycles in order to try to get the CPU patches in as soon as possible. So we'll kind of jump out right now. We'll go into the actual CPU here and bring up the CPU advisory. Most of the CPU advisory is really boilerplate. We kind of skip over it. The only information here, it says 57 vulnerabilities, but that's somewhat meaningless because there's so many Oracle products involved. The next thing to look at, and we'll talk about this much more detail looking forward, the key is that there's very few Oracle database versions supported. So if it hasn't been released in the last 18 months or is a terminal release, there is no support for certain versions. And I have a different chart coming up to give you some actual dates of when these versions will even go out of CPU support. Even though it's maybe supported as a database level, it tends not to be supported for the CPUs. And this is one way for Oracle support to kind of move you along with a stick. Kind of move now more through the CPU. The rest of it's basically boilerplate, shows up the same thing every quarter. And what we'll do is jump right down to the risk matrix, because that's really what we're all interested in here. So this is a standard risk matrix, and this is kind of the first thing you look at when you're thinking about the CPU. One of the key pieces of information on here that's useful beyond just the CPU is the CVE number. The CVE number is a standard common vulnerability enumeration. So most security vulnerabilities found in all products get a CVE number, and it's basically the year and a sequential identifier. So if you search for CVE 2011 2301 in Google, that will actually show you a number of other references. So if a security researcher found it, they often publish that information out on mailing lists about more details about actually what the vulnerability is. If there's exploit code written, they actually include the CVE number. So if you want more information on a specific vulnerability or questions, the best thing to do is just take the CVE number and actually search for it in Google, and you can actually get quite a bit of information for a lot of security bugs. And that's kind of a nice thing that Oracle has moved to in the last couple of years. The next area we look at is what package or privileges required. So this is supposedly one of the most severe bugs in the CPU. Well, you need execute on this one particular CTX-SYS package. Well, that's not granted to public normally, and so you either have to specifically grant it to that, which is not a normal situation because it's kind of more of a utility package, and in only very rare circumstances would you be granting execute on it, or you didn't need execute any procedure. So even though this vulnerability was scored an 8.5, the privileges required to this are actually fairly steep and would be somewhat difficult to obtain in a normal database unless you're granting out execute any procedure. Another thing to look at is what's the impact. So I can go through the network and its medium access complexity. Those are kind of typical for most Oracle vulnerabilities. And then Oracle puts out confidentiality, integrity, and availability. Confidentiality means I can read data I shouldn't be allowed to. Integrity means I can read or write data I shouldn't be able to. And availability means I can stop access to the database. In this case, very rare is a situation where I get a complete. And what a complete means is I can actually take over and escalate my privileges at the operating system level. It's very, very rare for Oracle vulnerability to ever have a complete on a Linux or Unix system. And most often when you see it completed in Oracle risk matrix, that means it's only for Microsoft Windows servers. And in this case, the note 1 here to the right is actually what that's saying. Then finally, the supported database versions is another aspect. As we see go through some of these other vulnerabilities, we're actually seeing partial pluses. So these vulnerabilities, again, mean I can take over the entire database. And in this case, in a core RDBMS issue, I only need these privileges and I can take over your entire database. So as long as I have those privileges, I can connect to your database, I can take it over. Some other aspects here are the products. So database vault is included. So out of this set of issues for this quarter, unless I'm running database vault, I'm really only accessible, exploitable by two or maybe 3. So again, Application Express may not be installed in my database. Core RDBMS, this is the serious one here. That one is most likely I'll be able to be exploited almost any database installed in the world. While Oracle Text may or may not be installed for like Oracle E-Business Suite and most applications, Oracle Text is installed. So in this case, probably 2 out of the 5 vulnerabilities are applicable to almost everybody on this call for almost every database they have. Where Application Express may not be installed, and Oracle Database Vault is probably used by a minority of the people on the call today. So those are the kind of things that we look through when we're actually looking through the risk matrix for each quarter. Just to give you a little idea of some of the information included and how you can use that information. Again, here's a 5.5 for a vulnerability. I only need some basic permissions, vulnerable in every database. Partial plus means I can take over in every single database, and it only rated a 5.5. So the Oracle CVSS scores that are listed in the risk matrices are low, and it's partially the problem with the CVSS risk rating versus anything else. So we'll kind of jump back now. Just that gives you a little bit of an idea of some of the things that we're looking at and talking about when we're looking through the risk matrix. So now we'll kind of go back and talk about some of those vulnerabilities specifically, and there's basically just a couple this quarter. So I'll split them off. So I'll talk about the 4 database ones first, and then I'll actually talk about the Application Express. So out of the 4 vulnerabilities, the first one was in Oracle Text. Oracle Text may or may not be installed. Basically, if you look in your database and see a CTX-SYS account, that means it's installed. And it's basically a buffer overflow. And at a very, very high level, what a buffer overflow is it's in a piece of C code, and in this case, it's a library. And the developer said, well, the person is passing in an object name, so obviously the object name can't be longer than the standard Oracle database object name, so I'm assuming that's maybe like 255 characters or something. And so the person writes their C code that way. Well, anyone who's ever programmed in C code knows that if you can overflow the buffer, bad things start happening. And in this case, there was no proper checking on the object name length or the index name length. And what will happen is that extra code has to go somewhere. And if you're very clever and spend a little bit of time, you can actually get that extra code that you pass in. So what I do is I pass in maybe 255 just random characters, and then after that I have carefully crafted hexadecimal code that actually becomes assembler code that gets executed as the owner of the database at the operating system level. In this case, it would be the Oracle account, that's what most people use. And then I can start doing things at the operating system level by just calling this database package and passing in some really bizarre string that most people say, wow, what does that do? And if you know a bit about assembler and how that works, you can actually do some really cool things in this package. The issue I have with this vulnerability is, well, I need to have execute on this specific package, or I have to have execute any procedure privilege. And that's kind of hard to get. So this is one of those vulnerabilities. While it rates pretty high, it's very damaging if I can execute it. But most likely in very high percentage of Oracle environments, I wouldn't be able to do this. Because a lot of people don't execute or grant out execute any procedure. And if you do grant out execute any procedure, oh, by the way, they can execute any procedure and take over your entire database a lot easier than actually executing a buffer overflow. So in the grand scheme of this vulnerability, we kind of rate this one as a low just because it needs significant privileges, but the risk of it being exploited is high. The second vulnerability is actually an interesting one because it's actually a SQL injection in dealing with spatial indexes. So when you kind of do a drop index on a spatial index, because spatial indexes are unique, and this is in the core of the database, Oracle Spatial does not need to be installed because it's kind of a key core feature. Basically, I can then execute code as SysDBA, and the reason I need create procedure is I need to be able to call back to something. I also need create table in order to work with the indexes. There are other ways around this. You do need create session and you do need create table to execute this specific vulnerability, but the create procedure is actually somewhat optional in certain applications. So like if you're running Oracle E-Business Suite, there's enough things I can do with the Oracle E-Business Suite and enough things granted to public in a standard database where I wouldn't need create procedure. In a pristine install of the Oracle database, yes, I would need create procedure and create table. But in many applications, the way they're designed is I really don't need create procedure to actually execute this very well. And what eventually ends up happening is I'm executing the code as the sys user or SysDBA, and I can basically do anything I want as the SysDBA user or role. I'll kind of jump out 1 second here and actually show you. A lot of questions people have, they don't really dissect the patches very often, which I assume you wouldn't want to very often because unless you want to go to sleep. But we'll kind of jump out the actual patch here and I'll show you some of the things happening. So this is an example of the patch. I've just had the zip file here, and this was the 11.202 patch for Linux, X32. So the 32-bit version. And you'll see different patch numbers within the patch. So there's a higher level patch, and then there's individual patches. And what these are basically are molecules, and so Oracle has gone to a little bit better patching system within 10.2 and 11G to actually avoid some of the problems with the merge patches and patch conflicts. And so when we go to a specific vulnerability, and there's actually a metalink note that maps the CVE numbers to each molecule. But if we go actually into one of these, it's just a standard Oracle patching. And we'll actually see for this specific Oracle spatial vulnerability what was fixed. And so the way this patch works is it's within this actual library. And so when you run the patch, it will actually rebuild this library. And what they do is just pass you some object code. And so this is the extent of a lot of changes for Oracle CPU patches. So this is fixing one vulnerability, but usually the vulnerabilities are very benign type issues. In this case, the programmer didn't properly sanitize some input that was coming in, which therefore allowed SQL injection. They should be asserting in the code that I'm passing in an index name. It's a valid index name. It's not an index name with a bunch of SQL after it that I want to execute as the SysDBA user. And so what Oracle has is some standard packages within the database, and I'm just asserting that, checking that, yes, this is a valid index name. And so all they did was actually make some changes to the SQL statements that are included in these object files, which then get compiled to make a library, and that's the fix. The fix isn't that significant. There aren't a lot of files here. These are just a couple object files, and if they actually look through and checked out what was changed, all you're seeing is a couple of SQL statements changed. So a lot of people question about, oh, how much do you have to test? How significant is the testing? And most, probably 90% of the CPU fixes are at this type of level that the only thing's changing is Oracle's checking that, yeah, when you pass an index name or something, or an object name, that should be an object name. It shouldn't be an object name and some other bad stuff attached to it. And so that's just an example of fix. And if you kind of go through the CPU patches in detail, you'll see those are basically the level of fixes and how extensive they are. They aren't very extensive and therefore don't need much testing. And that's why when you apply them, there really isn't a lot to test. It doesn't cause problems very often. And yes, they do cause problems sometimes, but generally the CPU patches are pretty good, especially on the database side. So that was kind of just to show you a little bit more about the CPU patch in detail and what fixed the second bug here. And so it's just a couple object files, and they just changed some SQL statements in those. The final two bugs specific to the database this quarter were in Database Vault. The purpose of Database Vault is to protect the SysDBA user and some other users from actually seeing data. You want to basically take your privileged DBA accounts and protect them from seeing your HR data or credit card data, things like that. And it's a problem if Database Vault can't do that, and you can circumvent the Database Vault protections. And that's exactly what this bug is. Someone went through and found an issue, and how can I circumvent the Database Vault protections? And in this case, there's a API package or call, OCI password change, that will allow me to change any password even though Database Vault's enabled and supposedly protecting the SysDBA user. Well, I'm supposed to stop the SysDBA role from actually changing something or reading data in the HR account. Well, if you can just go change the HR schema password, you can go change the data. And so basically there's these two CV fixes this quarter. One is actually, and the reason there's two, one actually fixes the SysDBA, and then the other one fixes the DV account manager, the Database Vault account manager role. So that's the two fixes. They're basically very similar because they fix what should be called. So at a high level, that's kind of to give you an overview of this quarter. There is no exploit code published. We like to give demonstrations if there is exploit code published, but we specifically don't develop exploit code, so there's not as much to demonstrate this quarter because no one has actually reverse engineered these patches and released detailed exploit code yet this quarter, which is positive from a security aspect. So listed with the 4 database vulnerabilities was also one in Oracle Application Express, affectionately referred to as APAX, which has had a number of security vulnerabilities over the years. And this quarter's is basically a very serious vulnerability that allows me to execute any code as the APAX user, and the APAX user typically is pretty much a privileged account. And the key is APAX must be installed and running to exploit this because it is exploited via the web. So if you do have a database with APAX, and the way APAX works, for those of you not intimately familiar with APAX, is it's basically database packages. And so if you remember the old ModTail SQL, and you can still use ModTail SQL or a number of ways to get into APAX, you call a web page from your browser and it goes to a listener, and basically what that listener does is redirects you to the database, and a package in the database executes, does its functioning, and then actually spits out a web page and returns it to the user. So the key is that there's a problem in the APAX code. All that APAX code is running as Oracle database packages. And so anything that I can do to exploit that code, I'm doing it inside the Oracle database. And so it's pretty powerful if I can find a security vulnerability. The APAX 6 is not included in the CPU database patches. And the only way to fix this vulnerability, which is fairly serious this quarter, is actually to upgrade APAX to the latest and greatest version, which can be problematic for many customers because if you're running an older version, you now have to do a major application upgrade along with fixing the security vulnerability. So it's not just install a simple patch, it's actually upgrading the APAX version. So if you're not on 4.1, most likely you're on, I think it's 3.2 or 4.0, you actually have to do an upgrade to 4.1 to actually get the patch. You have to do all your testing on the APAX application itself, make sure it doesn't break anything. If you don't know if APEX is installed or not, there's actually a pretty simple SQL statement that looks at the DBA registry view to actually pull up if APEX is installed. So I've included that here, which actually tell you what APEX version is installed. An interesting issue with APEX is that you can have multiple installations of APEX in the same database, but only one version is actually enabled at a time. So it does take a little bit of effort sometimes to actually figure out if APEX is running, because it actually can use one of 3 different models to run. It can use XBB HTTP, it can use ModTail SQL, or it can actually have its own listener. So there's actually a little bit of a complicated method, and we don't have a simple way to figure out if it's actually running. But you can find out if it's actually installed in the database. But then you have to figure out if it's actually using a specific version, because you can only use one version simultaneously within the database, but you can actually have 3 or 4 versions installed. So we've seen problems that people have patched before and actually patched the wrong one. In this case, is you have to upgrade to the latest one is the only fix for this quarter. So that's kind of a little bit about APEX. A lot of people use APEX to develop quick applications. We see a lot of DBA type applications actually written in APEX. DBAs, it's not too hard. You install the database, it's easy to keep up and running. Those applications tend to have access to a lot of data about what's out running as other systems and things like that. So for all the DBAs who wrote their own little APEX applications, it's time to patch. So that's kind of a high level of the vulnerabilities this quarter and some of the issues with those. And now we'll talk about some of the patches. I will cover a few aspects about CPU patches at a very high level first. And this is one area that we catch a lot of our clients when we do our on-site security assessments, and people run App Sentry. They're like, well, this result is wrong. No, it's not. What's happening is when you do database upgrades, let's say you're applying the 11.202 patch. It doesn't matter what prior version you had, and you said, well, I'm on the latest CPU. Then you run an 11.202 patch. What is happening with that patch is it resets your CPU level of the database because there's no versioning within Oracle database code. So whatever patch you apply overlays whatever there absolutely. And so now you're running the patch, you're updating the packages in the database. It has overwritten all your old code with CPU code of the day that version upgrade patch was released. So if you apply 11.202, and no matter what version of the CPU you have applied, it will revert you back to July 2011. And the same thing for eBusiness Suite customers on the phone. The same thing happens when you apply an eBusiness Suite upgrade patch. So the key here is whenever you do a database upgrade, always apply the latest CPU patch, no matter what, because unless you happen to run 11.203 and it happened to include July 2011, but that is not a very common situation. So whenever you apply a database upgrade patch, it reverts your CPU level back a number of quarters, and you always have to reapply the latest CPU, even though it had been applied on a previous version. And we catch a lot of our clients when we do security assessments on this issue, many more than you'd ever think. Another aspect about the CPU patches is that you must be on a supported database. Even though the database is supported, it may not have CPU support. And the Oracle standard is after 18 months of a release, there is no longer any CPU support. So the next version comes out. So right now, we're even looking at 11.202 as it becomes desupported for the CPU. The last CPU for 11.202 will be July 2012. Probably a lot of people on the call are saying, hey, I just upgraded to 11.202, and now I have a year to actually upgrade to 11.203. And that's the way it works. 11.201, last quarter, July 2011, was the last CPU. The only area where you do get a number of quarters after release is for the terminal release. So 11.107 is a terminal release, and Oracle basically gives you 5 years after that terminal release. So July 2015 will be the last CPU for 11.107. 11.205, again, July 2013 is these dates come back a lot faster. So if you're planning an upgrade cycles, you need to keep these dates in mind to make sure that you can keep applying CPUs. And this becomes a problem mostly for applications. When you start talking to the application owners and business owners, hey, we need to upgrade your database. Well, the application may not support it, or the business doesn't have time to apply CPU patches and things like that. So that has to be taken into account. And Oracle is very strict on these dates. They're very aggressive because they want to keep the number of versions, to a minimum level, so they don't have to develop the patches, and they can keep all their customers on common versions, which reduces their support effort. Another issue that comes up quite often and we get asked about all the time is patch set updates. So Oracle has critical patch updates, which is security fixes, but at the same time they also release what they call a patch set update. And a patch set update is what's included in the CPU plus other critical fixes. And these critical fixes tend to be database crashes or 600 errors. It's those type of things that are true bugs, can compromise the integrity of the database, but don't change the way the database works. So disk corruptions, database block, losses, etc. All that kind of just great bugs, but it doesn't change the way the database works. There's a couple issues with the way the patch set updates operate. One is it includes all these non-security fixes, so you have to have an appetite to apply those. And it's also updates the baseline version. When you apply a CPU, nothing changes to the version number. When you actually apply a PSU, it adds the last digit. So if you're on 11.202 and apply a PSU for this quarter, that number updates to 11.202 now .4. And so you can only apply PSUs because CPUs are only rated for the first version, so with no PSUs. So once you apply a PSU, you always have to apply PSUs moving forward until you do a database upgrade. And database upgrade would be defined as even a minor version upgrade. So if you went from 11.202 to 11.203, you do not have to apply PSUs anymore. You can go back to CPUs. But once you're on, until you upgrade, once you apply a PSU, let's say 11.202, you always have to apply PSUs to 11.202 once you've done it once. So the question is, okay, how bad is it? Well, how bad is a PSU? Well, we tore apart the July 2011 CPU and PSU for 11.202 to give you an idea. Within the CPU patch, there was 15 fixes total. Within the PSU, there was 110 fixes. So that included the 15 security fixes plus 95 more non-security fixes. That's a lot of non-security fixes to be included. What's our recommendation for customers when people ask? Well, if you apply one-off patches a lot, PSUs make a lot of sense because they're basically just including all those one-off patches in a semi-tested bundle. If you don't know what a one-off database patch is, you've never had to apply one, you never get little optimizer issues or database corruptions and things like that, well, a PSU probably doesn't make sense because it's just adding more risk. You're adding a lot of fixes you probably wouldn't run into normally. But if you're running a large data warehouse environment and some key performance databases that you have to apply one-off patches all the time, PSUs tend to make sense. So that's kind of our recommendation. So it's really looking at historically if you have one-off patches and if you have to apply them, the PSUs might make sense. Another question we get a lot is how do I check if a CPU has actually been installed? And since January 2006, Oracle actually keeps the table, registry dollar history, and that table keeps the last CPU applied. It should keep a full history, but based on different quarters, that may or may not be true. So I go by the assumption that it really only includes the last CPU, and you can't look back and see how many CPUs were actually applied, but it will always contain the last CPU applied. And the reason you want to look at registry dollar history versus the Oracle inventory, when you apply a CPU patch, it's a two-step process. You actually apply the patch using OPatch to the Oracle home, and then for each database out of that Oracle home, you actually have to run cat CPU SQL. The last step of cat CPU SQL is to update registry dollar history and insert a row. Until all the process is completed, there is not a row in registry dollar history. So if anything blows up, you forget a step or something, there won't be a row in registry dollar history, and that's kind of almost a guarantee. If it's in registry dollar history, there's a high confidence that the patch was applied successfully. One issue is if you roll back the CPU patch, it may or may not be removed. We had some issues over time with that happening. But if you kind of are moving forward applying patches, it shouldn't be a problem on registry dollar history, keeping a consistent consistently knowing what the last CPU applied was. The other way you can use the OPatch inventory and actually find out if it was applied to the Oracle home, but again, that doesn't include or reflect if cat CPU SQL was run. So if you forget to run cat CPU SQL, you'll see OPatch inventory says, oh yeah, it was applied to the Oracle home, but you may not know for sure if it actually was applied to the database, updated the database packages successfully. So that's kind of an overview of the patches, kind of a little bit more detail, kind of what's in the patches and what you need to be thinking about. So for a patching strategy, where do you lie? How often are you applying the CPUs, and do you have a successful process to do that? What we've done is actually gone through and taken the data that we obtained and anonymized it for all our clients that we've done security assessments for over the last couple of years. And so we looked at their high-end production databases. It's about 120 production databases. A lot of our work is on the ERP system, so this includes a lot of Oracle Business Suite, PeopleSoft, and SAP databases. And what we looked at was from the data, the assessment, how many months behind were the CPU levels. And as you can see by this chart, a lot of the clients that we've looked at, within 3 months they start applying them, within 6 months, and then 9 months, kind of the security conscious organizations are getting it within 6 to 9 months of release. And then you see a spike around 24 months. Typically what that spike is more related to database upgrades than anything else. And you see a number of our clients who, when we start our assessments, haven't applied them within 4 years. They're significantly behind, have a large number. So if you haven't applied it within 4 years, you probably have 100 vulnerabilities at least in your database that could be exploited. Well, what would be a best practice for an organization? Well, we see a lot of our clients going to, and what we recommend now is an N-1. So the goal is when the latest CPU is released, you've hopefully gotten the previous CPU in your production environment. So you're kind of going on a 3-month time frame to try to get a CPU patch in. Why is that doable, and how can you do that? Well, looking at kind of a timeline is if you're trying to get a CPU in, you first need a downtime for your production database, and that can typically happen within the 3-month or 90-day cycle. And so if you wait 2 weeks after patch release, and that's kind of our recommendation in case there's a reload or anything, then you start applying it to your development and test environments and going through a rigorous cycle with minimal testing, because we don't believe the CPU database patches need significant testing. And you get it in your development and test environments in that time frame. Well, you can at least have 3 to 6 weeks of it applied to test and development environments before you apply it to production, and you're kind of finding the correct downtime window in production in that time. So in our opinion, 90 days is a very reasonable time for database CPU patches, especially because minimal functional testing is required. We have some very big clients of ours who basically don't do much functional testing at all. They do some basic DBA testing, they get into test environments, and they let it run its cycle in test environments, because as we saw for the previous vulnerability and how it updated the library, the changes are typically very benign. It's not often that a CPU patch breaks anything, especially in the last year or two. When it first came out 5 years ago, yes, granted that there's a number of problems, a number of issues. But nowadays, the CPU patches, after 28 quarters, Oracle's gotten pretty good at it. There's now even a lot of merge patches as much as there used to be, and things move forward fairly successfully. So again, to reiterate, here's just a kind of another on the database upgrades, a little bit different version of it. So if you are doing a database upgrade, you need to be very aware of when you apply the database upgrade, you also have to apply the CPU patch. So as part of the patching process, when you do database upgrades, you're always applying the latest CPU patch. Again, as part of the patching strategy, this actually works out fairly well because you have to test the database upgrade anyways, and the CPU patch really doesn't add much more risk to the overall database upgrade. CPU patches go in fairly quickly and they add a little bit of time, but it really doesn't add much more risk to the overall database upgrade project. So if you're doing a database upgrade as part of your strategy, you should always be including the latest and greatest CPU patch, because you're probably applying that throughout test and development also at the same time. So when you start a database upgrade project, always make sure that the latest CPU patch is applied as part of the upgrade project. So there's a couple of common mistakes that we often see with the CPU patching. One is forgotten steps. As I talked about before, you have to run OPatch, but you always have to run the cat CPU SQL, We see that often with a lot of junior DBAs when they're doing the CPU patching for the first time is they run OPatch and they forget to run cat CPU SQL. Again, when there's a number of fixes within the CPUs each quarter, and a lot of times those update database packages, you might be updating a library, but probably 50% of the patches update packages. So the only way to get the package in the database is you actually have to run cat CPU SQL, and it takes the files that were updated with OPatch and actually puts them in the database. As I talked about before, the database upgrades. When you do the database upgrade, it resets the version, so you have to be very careful with that. And then Oracle Home versus database. It's not as common anymore to have a Oracle Home with multiple databases running out of it. You still see it for some older applications, but when you run OPatch, you run OPatch against your Oracle Home, and then you have to run the cat CPU SQL against each database. So if you have two databases out of one Oracle Home, you do have to run cat CPU SQL for each database. That's not very well documented in the Oracle READMEs. They need to improve that a little bit, and so some people do miss that. Another aspect, it's not as common at all, is you may have an Oracle Home, and you may actually run the OPatch against your Oracle Home, and you may wipe out the database and create a new database. If you don't run the latest cat CPU SQL, that database may not have every fix. Even though the packages may be recreated from the Oracle Home, there are steps within the cat CPU SQL that are specific to the cat CPU SQL, and some of them just revoke permissions and things like that, that aren't part of the Oracle Home otherwise, and are only contained in the cat CPU SQL statement. So as a idea is whenever you're creating a new database out of an Oracle Home, if the Oracle Home has been patched, you should always rerun the cat CPU SQL for each new database. So that was kind of at the high level. We went through the patches, the vulnerabilities, and kind of a patching strategy. And what we'll do is open it up for questions now. And also kind of display, if you ever have any questions on the Oracle CPUs, definitely let us know. We're very much open. We also have a blog that we publish out information each quarter about the CPUs and any additional information we receive. So I'll turn it back to Phil and see if there's any questions.
Thank you, Steve. We have several questions here. The first one, what is your recommendation regarding applying either a CPU or PSU patch? I think you may have just covered that.
Yep. Right. So just to reiterate, if you're kind of looking at the CPUs versus the PSUs, our recommendation is to look at if you're applying one-off patches on a regular basis, the PSUs might be beneficial. If you don't know what a one-off patch is, probably I would stick with CPUs.
Another one, bear with me, I'm not sure I understand it, but let me read it. We have a situation to upgrade database from 10.2.0.4 to 10.2.0.5 in order to apply July CPU, question mark?
So in a case when you're actually doing a database upgrade, so if you went from 10.2.04 to 10.2.05, you would have to reapply the latest CPU, because when you apply the 10.2.05 and kind of go back through the chart, when you applied the 10.2.05 database upgrade, you actually reverted the CPU level back to October 2010.
Got it.
I think that answered the question.
And the last one, there seems to be a lot of CPU questions today. The last one is, do the CPU patches have to be applied after doing a database upgrade? And I believe the answer is yes on that.
Yep. And the question is here is after you do a database upgrade, the key is, and this is not well documented, Oracle has finally in the last few quarters actually documented it in the actual upgrade notes, but if you actually just found it, I think a 10.2.05 upgrade note, it wouldn't say to reapply the CPU patch. So you have to be very careful about it because it's not documented. I think in 11.2.02, 11.2.03 upgrades, it was documented, but I don't think it was previous to that.
Okay, that's the end of the questions. So